Identify the relevant thermodynamic equation. The heat absorbed or released by a substance during a temperature change without a phase transition is described by the calorimetry equation. Q equals mc delta T, where Q is the heat transferred, m is the mass of the substance, C is the specific heat capacity, and delta T is the change in temperature, Tf, Ti. Identify the given variables for the water. Mass of the water, m, equals 200. G initial temperature, Ti, equals 50 degrees Celsius. Specific heat capacity of water, C, equals 4.2 J/G times degrees C. Heat transferred to the water, Q, equals 8.4 kilojoules. Convert the heat energy to matching units. The specific heat capacity is given in joules, J, while the transferred heat is given in kilojoules, kilojoules. To perform the calculation, convert the heat from kilojoules to J. Q equals 8.4 kilojoules times 1000 J over 1 kilojoules equals 8,400 J. Calculate the temperature change, delta T, of the water. Rearrange the calorimetry equation to solve for delta T. Delta T equals Q over mc. Substitute the values into the equation. Delta T equals 8,400 J over 200 G times 4.2 J/G times degrees C equals 8,400 over 840 is equal to 10 degrees Celsius. Determine the final temperature, Tf. Because heat is transferred from the hot iron ball to the water is absorbing heat. This means its temperature must increase. Delta T equals Tf. Ti, therefore Tf equals Ti plus delta T. Tf equals 50 degrees Celsius plus 10 degrees Celsius equals 60 degrees Celsius. This matches option C. The correct answer is option C, 60 degrees Celsius.